RSA Algorithm. It was invented by Rivest, Shamir and Adleman in 1978. RSA is an algorithm used by modern computers to encrypt and decrypt data. RSA is one of the most secure way of encryption. RSA algorithm is a public key encryption technique. Public key encryption, also known as asymmetric key encryption. Asymmetric actually means that it works on two different keys. One is public and another is private. The public key is used to encrypt the data and the private key is used to decrypt the data. The public key is given to everyone and private key is kept private. The key used to encrypt data in RSA is public key, that is distributed to everyone, but the private key is used to decrypt, that kept private. Now see how actually encryption works. The sender sends a message, "Hi, I am sender." But before sending that message, it is converted to a ciphertext using a public key. Then the ciphertext is sent through the communication channel. If an attacker tries to access the data, he gets only the ciphertext. It is unreadable by a human or computer without decryption. In the receiver end, receiver receives the data in the form of ciphertext, then decrypt using private key. Select P and Q. P and Q are integers and also prime numbers. For key generation, both the prime numbers must be large. The key size in the range of 1084 and 2048 bits seems safe. Small primes are not used in RSA. Now, calculate the product of both the primes P and Q. The value taken as 9. Then calculate the Euler twoshend. The Euler twoshend is the product of P minus 1 and Q minus 1. Euler twoshend is the number of positive numbers less than n and relatively prime to n. Now consider an example. I take two prime numbers. Let it be P equal to 3 and Q equal to 5. The product of these numbers is 15. Then the Euler twoshend is 8. That means there are 8 numbers less than 15 and relatively prime to 15. That means greatest common divisor of 15 and each of these numbers is always 1. Select integer e. There are two conditions. The first one is the greatest common divisor of e and the Euler twoshend must be 1. And the second condition is e must be greater than 1 and less than Euler twoshend. Now consider an example. In this example, Euler twoshend is 8. The possible value of e are 3, 5, 7. Check the two conditions. Greatest common divisor of 3 and 8 is 1. 3 greater than 1 and less than 8. To calculate d, the given equation is used. There is some calculation needed for finding the value of d. The pair of e and n taken as public key. The pair of d and n taken as private key. This public key is used to encrypt and private key is used to decrypt. That is, the value of n must be less than integer value of m. To encrypt the message m, use the equation m raised to e multiplied by mod n. To decrypt the message from ciphertext, use the equation c raised to d multiplied by mod n. Now, consider an example. Select two prime numbers p and q. P equal to 7 and q equal to 17. Calculate the product of these numbers, that is 119. Calculate Euler quotient, that is 96. Select an integer e. It must be satisfying the given two conditions. Here, 1 taken e equal to 5, then determine the value of d using the given equation. We get d equal to 77. The values 5, 119 are used as public key and the values 77 and 119 are used as private key. Now, let's talk about the process of encryption and decryption. Consider a message 19. It is encrypted using the public key that we see in the previous example. The ciphertext is produced, the value is 66. To decrypt the ciphertext, the private key is used, then decrypt and yet the message 90 that's sent by the sender. RSA is a secure algorithm since we use large number of bits E and D. The problem of factoring n into two prime factors is computationally very difficult. Knowing p and q will allow us to know Euler quotient. This will help an intruder to know the values of e and d.